Welcome back to part 2 of our series dedicated to machine learning. In part 1, we went over what machine learning is and how it works under the hood. Let's make this real with 3 examples that tie directly back to the steps that we discussed in part 1. The first example is classifying tumors as benign or malignant. This is a classic machine learning task. Say we want to help doctors determine whether a tumor is benign, so non-cancerous, or malignant, just cancerous. If we go back to the steps that we described in part 1, we would start with step 1, collect the data. We collect a dataset of past tumor cases. Each entry includes tumor size, texture, shape, and a label saying whether it was benign or malignant. Step 2, we pre-process the data. We clean the data, make sure units are consistent, remove incomplete records, and convert labels into numbers that model can understand. For instance, we would use 0 for benign and 1 for malignant. Step 3, choose a model. Since we want to categorize things into 2 groups, we use logistic regression. This is a very simple mathematical formula that works well when the outcome is binary. Here, either benign or malignant. If you are curious, you can Google it to see what the formula actually looks like. Step 4, train the model. The model starts with a basic formula and gradually improves it, trying to find the best mathematical equation that links tumor characteristics to the correct classification. Every time it's wrong, it updates the formula a little bit. Step 5, test the model. We test it on new tumor cases to see if it correctly classifies them. If it performs well, it can assist doctors in making faster and more informed decisions. Now let's look at another example, predicting hospital readmissions. This is about improving hospital operations and patient care. Again, step 1, collect the data. We gather data on patients who were discharged, including age, diagnosis, treatment type, previous admissions, and whether they returned within 30 days. Step 2, pre-process the data. We clean it up, handling missing data, convert dates into useful numbers, like time since last visit. Step 3, choose a model. This is a classification problem because the outcome is binary. Either the patient will be readmitted within 30 days or they won't. Logistic regression is again used here. It's a classification model that doesn't just say yes or no. It calculates the probability of readmission. This way, we get both the likelihood and a clear decision, which is very helpful for prioritizing patient care. Step 4, training the model. The model learns the relationship between patient history and readmission risk by adjusting its internal formula to reduce prediction errors. Step 5, test the model. On new patient records, the model predicts which patients are most at risk. Hospitals can then use these insights to offer extra support, helping reduce avoidable readmissions. And example 3, predicting the length of hospital stay. This time, instead of classifying into categories, we want to predict a number. How many days a patient will stay in a hospital. Again, step 1, collect the data. We gather patient records, including age, type of surgery, vital signs, and how long similar patients stayed in the hospital. Step 2, pre-process the data. We clean and prepare the data, ensuring all values are consistent and numerical. Step 3, we choose a model. Since we want to predict a continuous value, a number of days, we use another mathematical formula called linear regression, which is perfect for estimating a number based on input features. Step 4, train the model. The model learns to find the best formula that connects patient characteristics with their length of stay. It keeps adjusting its equation to make its predictions closer and closer to the real numbers. Step 5, test the model. We give it new cases and see how accurate its predictions are. If it performs well, hospitals can use it to better plan resources and schedules. So see, these aren't just abstract ideas. They're real tools helping to improve patient care every day. So what have we learned in this two-part series? First, machine learning is about teaching computers to recognize patterns in data. Second, it's a step-by-step process. Collect data, clean it, choose a model, train it, test it, and apply it. And last, but certainly not least, the core of machine learning is math, not magic. Understanding machine learning doesn't require a PhD. It just requires curiosity and a willingness to look past the jargon. So next time someone drops the term machine learning, you'll be ready to nod, not in confusion, but in confidence. That's it for today's episode of Tech Anatomy. If you found this episode valuable, make sure to follow the show on Spotify, Apple Podcasts, or wherever you're listening, and leave us a 5-star rating or a quick review. It helps more people discover these conversations. Tech Anatomy is produced by MedShake Studio, a leading podcast production studio dedicated to healthcare. Thank you for listening, and I'll see you next time.